This lesson is on 5.4 and we're going to be going over quadratic applications for the third time. So this is our third day of word problems and there's really nothing new. We're just going to give another example and go over it again. Okay, so let's get started. A football is punted into the air. Its height, h meters after t seconds, is modeled by the equation and they have it right here in standard form. Okay, so I drew a little bit of a diagram on the right-hand side. Notice that on your y-axis, we're talking about height in meters, and then on your x-axis, we're talking about time in seconds. Now, what you have to do is you have to look at each question and kind of understand or decode what they're trying to ask you so that you know what to do. And they're saying, what is the height? Which means you're looking for h. And that's why I have an h blank. Okay, that's what we're trying to find. When it was first kicked. So first kicked must tell you about the time because I have to be able to sub a number into the equation so that I can find h. And so if we take a look at where it was first kicked, the time is 0, almost as if like someone else, like a coach or something like that, is pressing a stopwatch, and as soon as they press a stopwatch, so time 0, that's when the punt happened. Okay, and so notice that I sub 0 into the equation wherever there was a t before, and I start to solve. So we do a little bit of BEDMAS. We go exponents first because we're going to deal with the brackets and the exponents. Okay, so 0 squared is going to be 0 right here. Okay, and then you know that 0 times anything is just going to make these guys go away. They're just zeros. So really all you're left with is the intercept, the h-intercept, right? We'd always said that the standard form gives you the h-intercept right there, and that's what this point is right here. So that number is 0.776, which means that as soon as it was kicked, it was actually already 0.776 meters off the ground. All right, and that's the first question. See, we're just decoding what each question is asking us for and solving algebraically. So question B, what is the maximum height of the ball? So they're looking for this part right here. What is the height? All right, and how long does it take to reach that height? So in other words, what is the time that happened? So you're looking for the vertex. Now, right now, it's in standard form, which isn't very helpful. We don't see the vertex right away. And so if you want the vertex, you're going to have to convert it all the way. So completing the square in order to in order to change it and convert it into vertex form. Because in vertex form, you can see the vertex very easily. So I'm not going to go over all the steps for completing the square because I expect that you guys already know how to do that. And so just looking at the answer, these two numbers right here, your h and your k, are going to give you the vertex. Just remember that the h is the opposite of the negative 2.4, which is a positive 2.4. Now, what do those numbers actually mean? Well, those are your numbers right here and here. So 2.4 goes right here, and then your 29 goes right there. Okay, so you can answer the question now. At 2.4 seconds, that's when the football in the air reached a maximum height of 29 meters. Okay, let's just keep going. What is the height of the ball after 2 seconds? Okay, so this one is saying, what is the height? You're looking for h. And then the time is 2 seconds. So obviously what I'm going to do is I'm just going to sub 2, whoops, thought I had my highlighter, 2 into wherever there was a t in the equation. Okay, and then you're just going to use your BEDMAS. So 2 squared is going to be a 4. Then you're going to calculate this multiplied together. You're going to get the negative 19. Multiply these two together. You're going to get the 47. And then you have the 0.776 at the end, put them all together, and you get 28.216. So at 2 seconds, the football is 28.216 meters in the air. Now, here's a very interesting question. At that time, is the ball going up or down? And so let's really understand, based on my diagram, what's happening. You were just asked at 2 seconds, what is the height? And you calculated that that was actually the 216 meters. And so already, since you know that the vertex happens at 2.4 seconds, then your ball must be continuing to go upwards when it's the 2-second time right here. Okay, so your ball is actually still traveling upwards at that point. All right, and you can also see that the height hasn't reached the maximum height yet, so it's actually still going up. Okay, so that's our first page. Let's go into the second page. It's some more questions based on the same thing. Is the ball still in the air after 5 seconds? Okay, so is the ball still out in the air after 5 seconds? Well, let's take a look. We're just going to put 5 into our equation. We're going to do all the calculations, and we get this really weird negative number. How can height be -4 meters? Like, did some person, they kicked the football into the air, it came down and came down so fast that it went 4 meters under the ground? Like, that doesn't even make sense. So I would say, no, it's not in the air anymore because the height can't be a negative. All right. And if we go back to our original diagram, that should kind of make sense, because if I zoom in, do you see how it takes, see how it takes 2.4 seconds just to reach the maximum? Then shouldn't this be another 2.4 seconds? So this is 2.4 seconds. This is another 2.4 seconds. You should be like, it should be reaching the ground about 4.8 seconds or something like that, right? So at 5 seconds, it shouldn't really be in the air anymore. Like, it should be somewhere down here. Okay, and that's why you got a negative number for the height. Okay, let's go back to the final question. How long does it take for the ball to hit the ground? Okay, so let's analyze this question a little bit. How long? What is my time? So if you're looking for your time, they must have given you your h. And when it says hit the ground, this is the clue. Your height is 0 when it's on the ground, right? There is no height. That's what the ground is. The ground is our 0 line. So notice that I had an h here in the equation, but I replaced it with the 0 this time. And now we're solving for our t's. Now, if we're solving for t's and you have a t squared and you have a t and everything is in like a trinomial, you can either A, factor, or since there's so many decimals, I think the best thing to do, is to use a quadratic formula. Okay, so putting everything into the quadratic formula, remember to change the x into a t because we're dealing with t's now and you're trying to find the times. All right, so this is your A. Put it everywhere in the equation where you would find an A for your quadratic formula. Anywhere you see a B, you're going to put it into the B for the quadratic formula. And then anywhere you see a C, you're going to put that number into the quadratic formula. Okay, now going through all the calculations, I end up with 2 answers at the very end. So this positive and negative will give 1 positive and 1 negative. So one is -23 plus 23. That's this guy. All right. And the other one is going to be the -23 minus. So it's going to deal with that -1. So that's this guy. We're splitting it into 2 answers, basically. And then we're going to solve. So this one gives you 1 answer, or you get another answer. So let's understand what both of those answers mean. When I had my parabola, and that was time, and this was height, and here is a person, and they're kicking a ball. It's going to go up and then it's going to go down. What you guys just found were our two t-intercepts here and here. So I have to extend the parabola just a bit in order for it to hit the ground. This one is the negative 0.03 answer, and this one is the 4.83 answer. So if we're going to ask, when did the ball hit the ground? It hit the ground at this one, not this one, because there's no such thing as negative 0.03 seconds. So the ball is going to take about 4.38 seconds to go into the air and then land back on the ground. And that is the end of all of our word problems.